Hi, welcome back to Missing Chemistry. This is gas stoichiometry lesson number 1. Alright, so gas stoichiometry invokes both gas laws and the concept of stoichiometry, which we discussed earlier this year. The reaction 2H2 plus O2 yields 2H2O. Given 10 liters of oxygen and excess of hydrogen, how many liters of water can be made? Remember that the excessive reactant is the reactant that we cannot use when we're trying to figure out how much stuff we made. Because the limiting reactant gets all used up, and once it's all used up, there's no more. So our oxygen is our limiting reactant. When it gets all used up, like I said, the reaction will stop. Leaving what's left over is the excessive. Alright, so let's look at the first problem. So we take 10 liters of O2 and we'll convert it into moles of O2. And we're going to go with that 22.4 liters, remember? 1 mole is equal to 22.4 liters. In this problem, we're going to go from my liters to my moles to their liters. Pretty darn snarly, huh? So let's go ahead and get the mole ratio. It's going to be 1 mole of O2 to 2 moles of H2O. And then we want to convert that back into liters, right? So we go 1 mole of H2O to 22.4 liters of H2O. So let's go ahead and cancel out our common units. And when we do the math, we're going to get 20 liters of H2O. So, it's really kind of easy to do these kind of problems. I mean, they look daunting sometimes, but, overall, you can easily do these problems. So, let's look at our next problem, okay? So, we're going to go ahead and read that here. And what we've got is, we have got nitric acid can be produced by the reaction of gaseous nitrogen and carbon dioxide and water, right? If 708 liters of NO2 reacts with water, what will the volume of the NO gas be? All right, so let's go ahead and do that problem. So first thing, we have our balanced equation, so that's all good. So the next thing we need to do is go ahead and take our 708 liters of NO2, and we're going to convert that into moles of NO2, of course. Divided by, of course, 22.4 liters of NO2. Then we look at the mole ratio. There is 1 mole of nitrogen to 3 moles of NO2. So nitrogen oxide is. So we go 1 mole of NO on top and 3 moles of NO2 on the bottom. Right? And then we would convert that back into liters, I believe, of NO gas. Yes. So we put 1 mole of NO on the bottom and 22.4 liters of NO on top. So let's go ahead and cancel out our common units. And now what we're going to do is we'll take our calculator and we're going to do this problem. So we're going to take 708 divided by 22.4 divided by 3 times 22.4, and we get approximately 236 liters. Of NO. Pretty darn snarly, eh? But we'll see it back here at Missing Chemistry. Alright? Remember, Missing Chemistry!